Okay. Ali. Okay. Uh, so today we are starting a new lesson. Okay. Today we are starting a new lesson. Pay attention, everyone. Stop talking. Today we are starting a new lesson. That's why I was waiting for a few minutes until everyone arrives. But the starting time is exactly 3:30 from next week. Okay. Can't wait more than that because I mean, since today is a bit of a change of plans, and since today we are starting a new lesson, that's why I was waiting for 10 minutes. So, online students, please confirm whether you can hear me clearly. Online students, please confirm whether you can hear me clearly. Okay, thank you. Thank you. So you'll be receiving the tunes by now in the Zoom chat. You'll be receiving the tunes by now in the Zoom chat and in the WhatsApp groups and in the YouTube live chat. Okay. Okay. And physical class students, anyone who didn't get the tute? Anyone who didn't get the tute? Anyone? Only. Anyone who didn't get the tute, please request for tutes. Raise your hand. Okay. Okay. So let's start with the lesson. Pay attention, everyone. Okay. Malik. Um, Pay attention, everyone. Stop talking. Focus here. Mali, start the recordings. Okay. So today we are starting a new lesson, rotational motion. Oh, okay. We can call it angular motion. Konika chalita hai. Angular motion. So this is not actually a new lesson. Okay. Not exactly a new lesson because this is just an extension of This is just an extension of the linear motion lesson, but we are going to analyze some stuff differently. Okay, we are going to analyze some stuff differently so that we can analyze rotational motion too. Okay, that is the target. So when we are talking about this angular motion, there are two types of angular motion. This proper definition of angular motion I'll discuss later. Okay, proper definition of angular motion, rotational motion, and circular motion I'll discuss later, because you'll be seeing we are using these terms like without giving a huge consideration for that. Sometimes I'll mention rotational motion, sometimes I'll call it angular motion, and later towards the end of the lesson I'll try to explain the proper meaning of this. Okay, but talking about this angular motion is actually change in the angle. Change in the angle. That means, or change in the orientation of an object. Okay, change in the orientation of an object. That means this is translational motion. This is translational motion, or a linear motion. That means although the object goes like this, no relative rotation between the particles of the same object. That means all the particles of the object travels the same path. All the particles of the object travels the same path. Clear? All the particles travel the same path. Okay. But if something happens like this, this one. See here, This particle travels a different path. This particle travels a different path, right? Here. In this case, definitely some kind of a rotation happens, right? Some kind of a rotation happens. That means the orientation of the object changes a bit. Clear? The orientation of the object changes a bit. Clear? This can be called as an angular motion. Clear? Then talking about this angular motion, there could be two types. One is rotational motion and other one is circular motion. What is rotational motion? Rotational motion is a rotation around an axis placed on the object. A rotation around an axis placed on the object. That means the object rotating around it. Object rotating around it. Clear? That means the object rotating around it. Clear? That means the object is rotating relatively. Clear? Object is rotating relatively relative to a particle on it. Clear? That means this is the axis. It rotates around that axis. Clear? It rotates around that axis. The rotation happens around an axis placed on the object. Okay? Pay attention. Then the next one is circular motion. Circular motion means again a rotation. Okay? Again a rotation but happening around again a rotation but happening around an outward point. That means the whole object is rotating. Whole object is rotating. Clear? Whole object is rotating but around a axis placed outside the object. Okay? The full system is rotating. The object as a whole is rotating around an axis placed outside of the object. Clear? So we are going to analyze these two scenarios. Okay? We are going to analyze these two scenarios. Okay? So what we are going to like, can you remember in linear motion we define something called linear displacement. Then we define something called linear velocity. Then we define something called linear acceleration. Okay? Like that we kept defining new stuff. Okay? Ali, check the messages quickly. Quickly check the messages. And make the tunes available in the YouTube live. Some students are mentioning that the live is not available. Check quickly. Okay, pay attention. Now you can move to the YouTube live if you need, okay? It's also running now. Pay attention. Pay attention. Now, Like if we try to analyze this rotational motion or angular motion separately as a new lesson, it takes a lot, okay? It takes a lot if we try to analyze this thing again separately, okay? Okay. So what we are going to do is we are going to create a relationship. We are going to create a relationship between linear motion and angular motion. And we are going to use whatever we learned in linear motion to understand angular motion. Clear? What we are going to do is we are going to create a relationship between linear motion and angular motion. And we are going to use whatever we learned in linear motion to understand angular motion. That means we start this with the, so we have a displacement, velocity, acceleration, everything in linear motion, okay, not in angular motion. So what we are going to do is we are going to use the definition of radians. Can everyone remember the definition of radians? Can everyone remember the definition of radians? What is the definition of radians? Pay attention. Radiant angle was defined. Radiant angle was defined if this distance is s. Stop talking, everyone. Stop talking. Radiant angle was defined if this distance is s, if this radius is r, if this radius is r, if this angle is theta, theta radians was defined as s over r, s over r. Okay, so theta radians equals s over r. This is the definition of radians. We get the length of this part divided by the radius, we get the angle in radians, okay? This is the definition of theta angle in radians. Now, this provides us with a huge support, that is, I'll just cross multiply here, then I would get s equals r theta. S equals r theta, okay? We get s equals r theta. Now what is this? What is this? Theta angle. What is this? A length. A length. When this angle is really small, we could call this displacement too. That means this is a kind of displacement, right? That means when theta is really small, I mean, we definitely don't, there's no such requirement to make theta small, but actually this is a length. This is a length. A linear length. A linear length. This is an angle theta. Okay. Now, usually when theta is really small, when theta is really small, this could be considered as a displacement, right? This could be considered as a displacement, right? So again, here also I can write theta equals s over r. S equals r theta. Clear? S equals r theta. Now, what is nice here is this is linear displacement, right? This is linear displacement. Okay. At the same time, what is this? At the same time, what is this? What is this? We call that angular displacement. Angular displacement means angle rotated by an object. Clear? Angular displacement means angle rotated by an object. Clear? That is angular displacement. So, in the linear world, this is displacement. In the angular world, this is displacement. They are connected by the radius which the rotating object travels. Clear? So the best thing here is we could create a relationship between linear displacement and angular displacement. We could create a relationship between linear displacement and angular displacement using the radius. S equals r theta. Okay. Now again, what is best here is you divide S equals r theta. You divide both sides by time. You divide both sides by time. Then what do you get? What is the displacement over time? Linear displacement over time? We call that velocity, right? Velocity r. Again, nothing to wonder. What is angle over time or angular displacement over time? We call this angular velocity. This is the symbol we use for that. Clear? This is angular velocity. Clear? So again, see, linear displacement over time, linear velocity, angular displacement over time, angular velocity, they are connected by r. So v equals r omega. I'm just going to save a lot of time. Okay, we'll see. I'm just gonna save a lot of time because when we create the relationship, we can use whatever we learned in linear motion for this. Okay, got the idea? Okay. Now tell me, what is velocity over time? I divide both sides by time. What is velocity over time? Acceleration. Velocity over time means acceleration. Clear? Velocity over time is acceleration. You have r here. What is angular velocity over time? What is angular velocity over time? Angular acceleration. Angular velocity divided by time is angular acceleration. Okay? That is angular acceleration. This is the symbol we use for that, alpha. Clear? Alpha. Clear? Okay? So now see, S equals r theta, V equals r omega, A equals r alpha. Okay? All the linear quantities and angular quantities are connected with each other by the radius r. Clear? By the rotational radius r. Which is nice. Why? Why? What is the reason? You have a bunch of linear motion equations, okay? You have a bunch of linear motion equations. You have a bunch of linear motion equations. What are they? Linear motion equations are S equals ut plus half at squared, v equals u plus at, v squared equals, pay attention, u squared plus 2as, v squared equals u squared plus 2as. I think everything is available in your tute. Yeah. Sometimes some stuff how I have explained may be different in the tute. Yes, you can't exactly follow the tute, okay? You can't exactly follow the tute, okay? I'll come to the tute later. Because tute holds the proper explanations, okay? Pay attention. Pay attention. Tute holds the proper explanations, okay? That is the issue. So, v squared equals u squared plus 2as, okay? Got the idea? Then, what else? S equals u plus v over 2 into t. S equals u plus v over 2 into t. So again, I'll bring the required notations, I'll consider angular displacement is theta. Okay. Starting angular velocity omega naught. Let's take it as omega naught. Final angular velocity omega. Angular acceleration alpha. Okay. Angular acceleration alpha. Okay. So now, what is S? What is S? S is r theta, right? S is r theta. R theta equals, what is U? Starting velocity r omega naught. Starting velocity r omega naught. R omega naught. Definitely at your schools or maybe in other classes, how you learned this will be different. Okay. I mean, why go through all the trouble when you have done the same thing in the linear motion, right? Okay. Why should we go through the same trouble when we have done everything in the linear motion? Okay, why waste time for that? Okay, so r omega naught, okay, r omega naught into time. U means, S means r theta, right? S means r theta, clear? U means r omega naught, clear? Into time plus half. Acceleration is r alpha, right? Acceleration is r alpha. Again, t squared. Okay. So what you get here is theta equals omega naught t plus half alpha t squared. I'm going to do the same thing for all the equations. Omega equals omega naught plus alpha t. Omega squared equals omega naught squared plus 2 alpha theta. Theta equals omega naught plus omega over 2 into t. Clear? I'm going to do the same for all the equations. Clear? That means in linear motion you have S, U, V, A and T. Okay. This is linear displacement. What is the angular version of this? Theta. This is starting velocity. What is the angular version of it? Starting angular velocity, omega naught. This is final angular velocity. I'll call that omega. This is acceleration. What is the angular version of it? Angular acceleration. Time is time. There's no linear time and angular time. Okay, clear? There's no linear time and angular time. Time is time. Okay, clear? Time is time. Got the idea? So this is actually angular motion. Okay, this is angular motion. We are like done with 50% of the lesson. Okay, around 20-30% of the lesson is done by now. Okay, why? Everything you learnt in linear motion is similar here. Okay, instead of s equals ut plus half at squared, you have, what is the angular version of s? Theta. What is the angular version of u? Omega naught. What is the angular version of a? Alpha. V squared equals u squared plus 2as. What is the angular version of v? Omega. Angular version of u? Omega naught squared. 2. Angular version of acceleration? Angular acceleration. Angular version of s? Theta. Clear? Okay. Now, if someone gives you the starting angular velocity and asks you after 5 seconds what is the final angular velocity, you have the equations. Okay, you have the equations. Clear? To handle any motion kind of scenario. Okay, to handle any motion kind of scenario in linear motion, now you have a solution. Okay, now you can easily handle any motion kind of scenario, right? Okay. Why? Given 3 information, you can find the 4th one. Clear? Okay. So this is the beginning of angular motion. The way I have defined things in the book is entirely different, because you have the proofs. Proofs we already did in linear motion, right? Okay. That's not all. Okay. That's not all. Pay attention. Okay. Let's keep it here for now. That's not all. You have, pay attention, you have angular displacement time graphs. Okay. You have angular velocity time graphs, and you have angular acceleration time graphs. Okay. You have angular displacement time graphs, angular velocity time graphs, angular acceleration time graphs. You get the gradient of angular displacement graph. You get the gradient of angular displacement graph. You get angular velocity graph. You get the gradient of angular velocity graph. You get the angular acceleration. Everything is just similar to linear motion. Okay. Can you remember these things? You get the gradient of angular displacement graph. You get angular velocity graph. You get the gradient of angular velocity graph. You get the angular acceleration graph. You get the area under the curve. You get the area under the curve of the angular acceleration graph. You get the angular velocity. Clear? Angular velocity. You get the area under the curve. You get the area under the curve of angular velocity graph. You get angular displacement. Clear? Whatever happened in linear motion, there's nothing different here. Clear? Whatever happened in linear motion, there's nothing different here. Clear? Got the idea? It's the same thing happening again. Okay? It's the same thing happening again. So that's the basic idea, or else the beginning of angular motion. Okay? The beginning of angular motion. Everything is included in your tute actually. Okay? And there was a form for online students to fill to get the tutes delivered. So we'll be starting the tute delivery by this Thursday again, the next batch of tutes. Some students may have received already. Okay. So we'll be sending the next batch of tutes again this week, by tomorrow actually. So just fill that. Okay. Check the group and fill that. Okay. So got the idea? Got the idea? Everything is included in your notes. So actually there's nothing to write. Okay. There's actually nothing to write. So let's directly go to the, so everything that I explained is included in the chart here, right? There's a chart in your book in page number 6. Okay. There's a chart in the book in the page number 6. Everything that I mentioned is there. Okay. Everything I mentioned is included there. Okay. Okay. So again, for the completion, okay, for the completion, let's discuss about the units and everything about these guys. Pay attention. Pay attention. Unit of angular displacement is radians. Angles are measured in radians, right? Angles are measured in radians. Unit of angular velocity, radians per second. Radians per second. Clear? Unit of angular acceleration, radians per second squared. In linear motion, this was meters, meters per second squared. Here this is radians, radians per second squared. Okay, clear? Everyone did the definition of radians, right? Whatever the class you went. So I'll explain the definition of radians again when others are doing questions. Okay. Did you understand everything up to this point? Okay. So now okay. So let's quickly go to exercise 1. I mean just pretty easy questions, okay? Nothing important, okay? Nothing important. But just to revise the content, let's go to the exercise. Go to exercise 1. Go to exercise 1. Do first, second, and third questions. First, second, and third questions. Exercise 2, first and second. Exercise 3, first, second, and third one. Exercise 3, first, second, and third one. Write this down on your book. Exercise 1, first, second, third. Exercise 2, first, second. Exercise 3, first, second, and third one. At the same time, if someone can't remember the radians and definition of radians, I'll revise things again, okay? R means the radius, okay? R means the radius. Radius creates the relationship between the linear motion and angular motion, okay? Radius creates the relationship between linear motion and angular motion. It here. So if someone can't remember the definition of radians, okay? If someone can't remember the definition of radians, radians is a unit of angle, unit of measuring angles, and the radian angle was defined by taking a circle of radius r and the length of the circumference, if it is s, you get s and divided by r, the radius, you divide it by the radius, you get the angle in theta. You get the angle in radians, okay? You get the angle in radians. This is the definition of radians, okay? So in angular motion, the unit of measuring angular displacement should be always radians, okay? Don't write answers in degrees, okay? In all levels, you were more comfortable with degrees, right? Okay, 30 degrees, 60 degrees. But in the angular motion lesson, you can listen while you are doing the questions, okay? But in the angular motion lesson, because many of you guys have this understanding, but in the angular motion lesson, always the unit of angular displacement is radians, okay? Don't use degrees for that. Why? Pay attention. The relationship between the linear motion and angular motion holds only for radians, right? That relationships we created, okay? That relationships we created for linear motion and angular motion holds only for what? Only for radians, okay? S equals r theta works only for radians, not for degrees, okay? So in this lesson, you always measure the angle using radians. Then at the same time, if we need to create a relationship between degrees and radians, we can get what is a full circle? What is a full circle? What is the radian angle that belongs to a full circle? Then it is theta equals s over r. Full circle means 2 pi r. This s value of a full circle, is 2 pi r. Is 2 pi r. S value of a full circle is 2 pi r. Clear? Divided by r. 2 pi r over r. You get 2 pi radians. So one full circle means 2 pi radians, and you know that one full circle is equal to 360 degrees, right? You know that one full circle equals 360 degrees. Clear? So you divide this by 2 if you need. 180. So pi radians equals 180 degrees. This everything you know, okay? Everything you know, and everything is again included in your tute, okay? Although you know this stuff, everything is included in your tute, okay? Clear? Pay attention. Now, pi radians equals 180 degrees. Clear? Then 1 radian means, from this, 1 radian means you take pi here, 180 degrees over pi. Okay, like this you can create a relationship between degrees and radians. Okay, this is just a revision from whatever you have done up to now. Okay. Mali chat, main chat. Mali provide the truths again. Provide the truths again. Exercise 1, I asked you to do. Exercise 1, question 1, 2, 3. Right here. Exercise 1, question 1, 2, 3. Exercise 2, question 1, 2. And exercise 3, question 1, 2, 3. Mali. Mali. Okay. Let's start with the questions. There are, like in exercise 3, there's I think frequency and rounds per minute kind of stuff involved. I'll explain that. Okay. I'll explain that. Again, one thing, pay attention. I need you to write down these equations in a piece of paper, because in exercise 4 or 5, we have to start using these stuff, okay? We have to start using these stuff. Again, the same thing we did in linear motion, okay? You write down these 4 equations in a piece of paper, you look at the equation, and for now you apply the equations. Later you'll remember everything, okay? Later you'll remember everything. So take a piece of paper and write down these 4 equations so that in the exercise you can refer to them, okay? In the exercise you can refer to them. Take a small piece of paper and write down these 4 equations. Theta equals omega naught t plus half alpha t squared. Omega equals omega naught plus alpha t. Omega squared equals omega naught squared plus 2 alpha theta. Theta equals omega naught plus omega over 2 into t. Exercise 1. Exercise 1. Question 1. Part 1. A circular disc rotating about a fixed axis shows the following motion in 10 seconds. Everything happens in 10 seconds. Moves 4 round, find the total angle turned and the angular velocity. So angle turned means angular displacement, right? Total angle turned means angular displacement, right? So it's 4 rounds. It's 4 rounds. 4 rounds means 4 into, what is 1 round in radians? 2 pi, right? 1 full round in radians is 2 pi. Clear? Clear? 1 full round means 2 pi radians. So you get 8 pi radians. This is the total angle turned. What is the angular velocity? Angular velocity means angle turned over time. Angular velocity means angle turned over time. Angle turned is 8 pi. Angle turned is 8 pi over time is 10 seconds. Time is 10 seconds. Angle turned over time, or the angular displacement over time, is angular velocity. So you get 0.8 pi. 0.8 pi radians per second. Radians per second. Question 2 moves 5 rounds. So angle turned in 5 rounds means 5 into 1 round means 2 pi radians. 1 round means 2 pi radians, which gives you 10 pi radians. And the angular velocity is theta over time. Angular displacement over time. Angular displacement is 10 pi divided by 10 seconds. Time is 10 seconds. Then you get pi. Then you get 10 and 10 cancels out. You get pi radians per second. Pi radians per second. Third one, turns by 450 degrees. Then find the angle of rotation in radians and angular velocity. Turns 450 degrees. As I mentioned, never answer questions, okay? Never answer questions in angular. Never answer questions in degrees in this lesson, okay? Okay. So it's much convenient to convert things into radians. How do we convert things into radians? Quite easy. It is 450 degrees. If you like, you can write it is 360 degrees. It is 360 degrees for 2 pi radians, right? Clear? Oh, it's 2 pi radians for 360 degrees. Then how much for 450 degrees, right? Clear? It's 2 pi radians for 360 degrees. Then how much for 450 degrees? Clear? So you can solve this. 0 and 0 cancels out. Divide by 9, 4, 5, 5. So this and this cancels out and you get 2. Then you get 5, 5, 5. You get 5 pi over 2. 5 pi over 2. Radians. Radians. That means 2.5 pi radians. 2.5 pi radians. Then again the angular velocity omega is angular displacement over time, theta over time. Angular displacement is 2.5 pi, 2.5 pi. This is the angular displacement over, this happens in 10 seconds, right? In the question, everything happens in 10 seconds. So the angular velocity is 0.25 pi radians per second. Radians per second. Let's go to the fourth one of the same question too. Let's go to the fourth one too. Fourth one. Fourth one. Again 720 degrees, right? Again they are talking about 720 degrees. So you should write things in radians. 720 degrees means how many radians? It's 2 pi radians per 360 degrees, right? It's 2 pi radians per 360 degrees. Then how much for 720 degrees? So you get 2. You get 2. So you get 4 pi. You get 4 pi radians. 4 pi radians. Then angular velocity is angular displacement over time. Angular velocity means angular displacement over time. Angular displacement is 4 pi radians. Angular displacement is 4 pi radians. Time is 10 seconds. Then 0.4 pi radians per second. 0.4 pi radians per second. Let's go to exercise 2. I mean, you are capable of going until exercise 4, I think, okay? If you are done with everything, don't talk with each other. You are capable of going until exercise 5, okay? You can even do exercise 5, okay? From the things you learn by now, okay? From the things you learn by now, you can go up to exercise 5, okay? You can go up to the end of exercise 5. So if you have nothing to do, if you are done with the question, go to exercise 5 and finish that, okay? Exercise 2. Exercise 2. In a car race, 3 cars ABC moves with the same angular velocity 10. If A equals 50 meters, B equals 60 meters, C equals 80 meters, from the center of the track, find their speeds. So there can be several objects. Pay attention. Objects can have the same angular velocity but different linear velocities. Why? They may rotate the same angle in 1 second, But if the radius is different, okay, for the same angle, pay attention, stop talking. If the radius is different, for the same angle, they may travel different paths, okay? For different radius values, they may travel different paths. Like this, okay? Clear? So, people can have the same angular velocity, but different linear velocities when the radius is different, okay? So, in this case also, radius for A, B and C are 50, 60 and 80. Radius values are 50, 60 and 80. This is 50. This is 60. And this is 80. They are 50, 60 and 80. Clear? Radius values are 50, 60 and 80. Okay. So, you know that V equals R omega. V equals R omega. Omega is same for everyone, 10 radians per second. So, velocity of A is RA omega. RA means radius of A is 50. Radius of A is 50. Omega is 10. For B, radius is 60. Omega is 10. For C, radius is 80. Radius is 80. Again, omega is 10. So you get 500 here. 500 meters per second. Linear velocity is given by meters per second. Here this is 600 meters per second. Here this is 800 meters per second. 800 meters per second. Clear? So things may have the same angular velocity but different linear velocities based on the radius. That's the significance of radius of the track. Clear? Clear? What is the distance traveled by an object rotating 30 degrees on a path of radius 10 meters? Question 2. Write this down and ask if you have any questions, online students. Ask if you have any questions. So, are you done with the term test or having the term test or what? Done? Finish? Oh, physics paper is easy? Yes, right? You have the paper? Anyone have the paper? Ah, cool. Well, it's quite easy, right? Oh, I mean, pretty popular questions. So don't tell me you didn't get 25 out of 25 for this, okay? Yes, everyone. This is manageable. You have center of gravity too? No? Yes, right? No essay paper? Only an MCQ? Essay is there, it's not here. Okay. So, questions are good, but you should be able to get 25 out of 25 for this, okay? Have done thousands of questions like that. We did 30 something papers for Thursday class, 30 something papers for Sunday class, so altogether 60 something papers. If you can't get 25 out of 25 for that, I mean, it's a disaster. So don't tell me that you didn't get anything, that you got anything below 25, okay? Same goes for everyone in all the schools, okay? Same story, they can't give that, I mean, our papers are difficult than your term test papers. We did a lot of it, okay? We did a lot of it, so don't tell me that you got low marks for the term test, okay? I mean, in our time, papers were much difficult, okay? Like, I think I explained you guys, right? One time the paper looked like this. Pay attention. They gave a diagram like this. They gave a diagram like this, okay? Mentioned that this is a boomerang, okay? One full essay question, okay? If you have done past papers, you may have seen this twice, okay? This mentioned that this is a boomerang. Explain the function of it. That's the whole essay question, okay? This is one of the most complex functionalities in physics, okay? A boomerang. It involves Bernoulli principle, angular momentum conservation. There's no way of thinking that, okay? There's no way of thinking this mechanism. Why it returns? Why it returns? It's pretty complex physics, okay? Pretty complex physics. Then the whole essay question was this. There were only 2 essay questions for the paper. One essay question was explain this. That's all. Nothing. No words. No lot of words. Just explain the functionality of this. Okay. Nice papers we got, like, in some years. This was in, I think, I can't remember the year. In our second term test, but for 2017 or 15 students for the first term test, like that. Okay. So you should be able to handle, I mean, that paper, okay? Our papers were much complex, okay? But anyways, the paper is good. There are some good questions in the MCQ. Some good questions in the MCQ. And let me know if you find any question hard, we can discuss it here. Let's do that for all the term tests, okay? When term tests are over, let's get the term test papers and discuss the hard questions in the class, okay? Let's collect all the term test papers. Okay. Question 2. This is exercise 2, question 1. This was exercise 2, question 1. Now 2. What is the distance traveled by an object rotating 30 degrees on a path of radius 10 meters? Radius 10 meters. 30 degrees. What is the distance of the path? What is the distance of the path traveled? Okay. What is the distance of the path traveled? So now again, what is theta? S over R. S equals R theta. Okay. Radius is 10 meters, but never use degrees in these equations, okay? Okay. Always it should be radians, okay? So what is 30 degrees? 30 degrees in radians means 30 into, it's 2 pi radians for 360 degrees. It's 2 pi radians for 360 degrees. 0 to 0 cancels out. 3 and 12, pi over 6 radians. Pi over 6 radians. So angle is pi over 6 radians. Pi over 6 radians. So this is the distance traveled. This is the distance traveled. Okay. 5, 3, 5 pi over 3. 5 pi over 3 meters. It is in meters. Okay, pay attention. Before moving to exercise 3, um, I'll complete everything until now. Okay, I'll complete everything until now. That means, as I said, you can finish until the end of exercise 5 because we shortened the process a lot by connecting the linear motion and angular motion. Okay, what was supposed to be a very lengthy lesson, we shortened that. Okay, using the relationship between linear motion and angular motion. Clear? Which makes our life easy. For everything else, I'll do that. Okay, we will have an angular version of F equals ma. We will have an angular version of angular momentum conservation. We will have an angular energy conservation. Okay, everything, for everything after this, I'll do the same thing. Okay, I'll use the linear knowledge to bring angular knowledge. The reason is, pay attention, we did a lot of questions for linear motion. You have a lot of experience in linear motion. You're not going to be able to do the same thing for angular motion. So the best thing is using your experience in linear motion to handle angular motion. Okay, that is the best option here. Clear? So you should be able to use your knowledge in linear motion to understand angular motion questions. That's why I always go with the relationship between them. Okay, but for the completion, we need to know some other stuff too. These things are also included in your tute. Okay, except one thing, I'll explain this one too. Pay attention. Now it's easy to tell the equivalent of linear, pay attention, stop talking everyone. The equivalent of linear displacement is angular displacement. Equivalent of linear velocity is angular velocity. Equivalent of angular linear acceleration is angular acceleration. Okay. So this is angular displacement. What is the definition of angular velocity? Delta theta, change in displacement over change in time. Pay attention, stop talking, front row. Pay attention. Sorry? Yeah. Okay. So omega equals delta theta over delta t. Clear? Then what is alpha? What is alpha? Alpha is delta omega over delta t. Delta omega over delta t. Clear? Now, this is not complete, okay? These were vectors. These were vectors. These are also vectors, okay? These are also vectors. Now, what is the vector direction for them? These stuff are rotating. So, what is vector direction? Can I call clockwise, anti-clockwise as directions? No. Why? For these things to be vectors, they should have a properly defined direction. I can't call this is a clockwise direction, this is anti-clockwise. I can't call like that. Why? What is the reason? I mean, then how am I going to apply vector addition laws? How the hell I'm going to draw the vector triangle for this? Like this? Okay? I mean, any vector should be following all the vector laws. Okay? Any vector should be following all the vector related laws. Okay? So if I define these directions as this and this, how can I draw the vector triangle? Okay? Okay, like this I have to draw the vector triangle. Not a convenient way to draw vector triangles, right? Not a convenient solution. Okay? Then what can I do for this? Then what is the solution for this? Then the solution for this is, okay? The solution for this is, we define a method to define the direction of these quantities. They are, one is like this. We use the right hand law for that. Okay. That means if something is rotating like this, okay. If something is rotating like this, okay. Of your right hand, if the other fingers go in that direction, the thumb will show you the direction of this vector. Just a law created to define directions for rotational quantities. Now it has a linear direction, nice, clear? Now it has a linear direction. Now I can apply vector addition laws. How? See, assume something is rotating like this. That means the vector direction is this. Use right hand law. Vector direction is this. Here. Again, assume something is rotating like this. Okay. That means the vector direction is this. Vector direction is this. Now I'm capable of adding these two vectors, right? This vector plus this vector. This is the resultant vector, see? So when you define a proper linear direction for vectors, then only they become complete, okay? Then only they become complete. So behind this, there's a pretty complex mathematical background, okay? There's a pretty complex maths, like a bunch of maths behind this about these directions and all. It's not included in our syllabus, sadly, okay? So for us, it's just a law, okay? For us, it's just applying a law. Why? What? If something rotates like this, this is the direction. So if the angular velocity is this direction, this is the direction. If the angular acceleration is in this direction, this is the linear direction. Now I'm capable of defining proper directions for these vectors. Now only they are proper vectors, okay? Okay. But don't worry, in a question, okay? In a question, still you can mark the direction like this or this, okay? If they tell you that there's something like this and it starts rotating, okay? It starts rotating after 5 seconds. What is the rotation kind of thing? If they ask, you can just tell it's 5 radians in this direction, okay? Okay? Why? I mean, it's just for the question we can answer like that, but you have to keep in mind this is not the actual direction, okay? But in questions we show directions like this. No big issue there, okay? No big issue there, okay? Until you know the proper direction, okay? So another thing is, okay, now things are much complete, okay? Now things are much complete, and at the same time, you will see few more words. You'll see few more words in this lesson. One word is the periodic time. The periodic time. What is the periodic time? The periodic time is the time it takes to travel a full circle. Okay? Periodic time is the time it takes to travel a full rotation. Clear? Clear? You start here, you go a one full circle, you travel a one full circle and you return to the same point. Clear? So here periodic time is t. This is the usual symbol of periodic time. Okay. So I can write angular velocity. If I write the angular velocity using periodic time, what do I get? One full circle means 2 pi radians, right? One full circle means 2 pi radians. Clear? One full circle means 2 pi radians divided by the periodic time. Okay? This is angular velocity. Here, angular velocity. Because periodic time is the time it takes to travel the full circle. So you divide the angle of full circle by the time it takes to travel a full circle. You get the angular velocity. Clear? Clear? 2 pi over t. So if someone asks you to find the periodic time, this is the equation 2 pi over omega. Okay? If someone asks you to find the periodic time, this is the equation t equals 2 pi over omega. Clear? Then there's another term that you will see. There's another term that you will see in the lesson. It is the frequency. Frequency is 1 over t. Frequency is 1 over t. Okay. Frequency is 1 over periodic time. Clear? So, what is the actual physical meaning of this? What is the actual physical meaning of this? The actual physical meaning of this is how much per second. Why? Assume that n number of rotations happen in time t. N number of rotations happen in time t. Then what is n over t? What is n over t? Number of rounds divided by time means how many rounds per second. Clear? Number of rounds divided by t means how many rounds per second. Clear? Clear? How many rounds per second. Clear? Meters divided by seconds, that means how many meters per second. Okay? Kilometers divided by hours, how many kilometers per hour. Number of rounds divided by time, how many rounds per second. Okay? Now in this case, when n is 1, when the number of rounds is 1, how much time it takes to travel 1 round? How much time it takes to travel 1 round? A periodic time, right? It takes a periodic time to travel 1 round. Clear? So that is the meaning of frequency. How many rounds per second? Clear? How many rounds per second? Got the idea? And when it comes to the industry, okay, you will see these kind of units too. Revolutions per second, revolutions per minute, and RPM. Okay. What is revolutions per second? How many rounds per second? What is revolutions per minute? How many rounds per minute? What is RPM? Again, rounds per minute. That means how many rounds per minute. So you will see this information, RPM, always in question, because this is heavily used in industry, right? Even when you talk about vehicles and anything, right? Any kind of engine, okay? Any kind of engine, any kind of a vehicle, any kind of a industrial rotating body, they give information using RPM. They don't give information using radians per second. It's not convenient, okay? They don't give information using radians per second. Why? In the industry, they always prefer to use terms that are much understandable by common sense. So radians per second, do you feel anything? No, right? If someone tells you it's 10 radians per second, do you have any kind of idea whether it's too large or too small? 5 radians per second? 100 radians per second? No, right? But rounds per minute means how many rotations per minute? It's very close with the common sense, right? So then when you tell that engine rotates, that engine wheel rotates with 100 RPM, you have a slight understanding. If it is 20,000 RPM, yes, you know it's a lot. It's 20,000 rounds per minute. Okay? That's why in industry they always prefer like much closer, much units that are closer to your common sense. Okay? So I need you to do something. Okay? Since we are not writing a note here, now it's complete. Up to this point, it's complete. Now next, what we have to do is finish until exercise 5. Okay? Nothing else. Okay? We have to finish until the end of exercise 5. We have angular motion equations and everything. Now we have a good understanding about that. But before moving into that, you have two options. Go through your note from beginning to up to exercise 5 and underline the important concepts and like try to understand everything, or make your own short note. Make your own short note. So in 26 batch also, when teaching current electricity, what I do is I give a one full note, and in the class we are preparing the short note. We are preparing the short note. Even when I was going to classes, when I was doing A levels, I always did the same thing. In our classes, they didn't give this much of printed materials. Okay, it was always the note. Okay, actually we didn't get anything printed. We just got a note, huge note. Some students like that, right? You guys like writing a note, right? I later understood that. Okay, I later understood that after talking with a lot of teachers, lot of students. Who the hell like writing notes? I mean, but students like that to write a note. So you have a note, so you are pretty happy that you have done some amount of physics. And I always get that complaint. We have nothing left when we go home. No note. I mean, why the hell you need a note? It's just a question based subject, right? It's just understanding. But I always get that complaint. Okay, it's a very popular complaint that I always get. Even parents call and ask. I mean, there's nothing in the book. These, what the hell are you doing? Okay. I mean, I always get the same comment again and again. Okay, at least once per week. At least once per week, I get the same call or the message that we are not writing any note in the class. Why do you need a note? Okay, you have a properly functioning brain. Put things into your brain. Okay. Okay, but anyways, we should prepare a short note at least. Okay, so even when I was going to classes, our teachers gave notes. I never wrote the note. What I did was I wrote a short note, and later when I need the note, I got a photocopy of a student who made a nice note. Why? Notes never go through your brain. Okay, it's just word to text converters, right? You just hear the exact word the person is telling, you write that. Next word, you write that. Next word, you write that. That's why when we are reading too fast, you can't write. Why? You understand nothing. You just convert words into letters, right? But it doesn't go through your brain directly from ear to hand, okay? But short notes, you can't do that. You hear, you understand, then you should write, okay? Otherwise, you can't create a short note. So in the class, if you create a short note by yourself, there's nothing left to study, okay? Especially do this for chemistry if possible, okay? Especially do this for chemistry if possible. When you're going home, if you at the class, if you prepare a short note instead of writing the same thing mentioned by the teacher, instead of doing that, if you prepare a short note, that means everything have to go through your brain, okay? You can't write a short note without understanding. You're not directly converting things. Okay. So that's why I never studied anything. Okay. I never studied anything. In the class, I prepare my short note, then it's done. Nothing left to study. Okay. Nothing left to study. Because in the class, you have to understand before writing it when you're preparing a short note. Okay. So even in the classes that we didn't get a proper note, still I chose to write short notes. Okay. So convert everything you got, everything you find important until now into a short note if you need, or go through the note until this point and keep doing the question. Go to exercise 4, go to exercise 5. Write down the equations, how they were converted. Okay, and short note is not a note wrote in small letters. Okay, okay. Short note is not a note wrote in a small book in small letters, okay, with some colors. That's not the idea of a short note, okay. Don't write anything that doesn't have a good significance. Just the equations, okay. No letters, okay. Don't explain things. Your brain will do that thing, okay. Okay, just to revise content. Try to prepare on short note. Take 5 minutes. Mention all the content that we mentioned until now. You can go through your tute. Everything is included in your tute, okay. Everything is included in your tute. So go through your tute, prepare your own short note, and continue to exercise 4 and exercise 5. Okay. Go to exercise 4 and exercise 5. So exercise for 1, 2, 3, 4. Exercise for prepare your own short note. Then exercise for 1, 2, 3, 4. Then exercise 5. Exercise 5. One, two, three, 4, 7, 8. 1, 2, 3, 4, 7, 8. So if I was preparing a short note, well, okay. So if I was preparing the short note, okay. If I was preparing the short note, what I would write is h equals r theta, v equals r omega, a equals r alpha. Then the motion equations, rotational motion equations, 4 motion equations, rotational motion equations, then this, then this. That's all. That's all. Nothing more than that. Nothing more than that. Okay. Quickly go through your note. You should. Check. Check. So write your short note, then exercise 4, question 1, 2, 3, 4. Then exercise 5, question 1, 2, 3, 4, 7, and 8. Ask questions if you have any, okay? Ask questions if you have any. At least write a cheat if you have any question. If you can't do one question, skip that and go to the next one, okay? If you can't do one question, skip that and go to the next one. Ask if you have any questions. Ask if you have any questions. You guys don't have to write the JIT exam yet, right? No, right? JIT exam? Yes? No? Yes? No? You're not writing any exam on this Sunday, right? Nothing, right? No. So it's for, then it's for 26 students, right? No point of writing that actually, because even we still didn't get the marks for that. Now it's like 6-7 years after writing the JIT exam. It's not 6-7, is it 10? No, right? 2019, what is this year? 26? Yeah, 7. Keep doing the questions. Keep doing the questions. Exercise 4 and 5. And last row people, if you can't hear properly, if you have any kind of issue like that, please inform our people as fast as possible, okay? Don't wait until our people figure that out, okay? If anyone's having any kind of issue, okay? If you can't hear anything, or if what you're hearing is not clear enough, or if you have any kind of issue like that, quickly inform our people, okay? We'll try to correct that as fast as possible. Don't wait until someone mentioned that. Then half of the class is gone by then. Okay. So just quickly inform our people. Exercise 4. Exercise 4. Question 1. What is the angular acceleration of an object? Did we do exercise 3? No, right? We have to do exercise 3 first then. Exercise 3, question 1. A fan rotating with uniform angular velocity rotates 5, 10, 20 revolutions per second. Find the angular velocity. Find the angular velocity of the fan. Find the angular velocity of the fan corresponding to each case. Okay. Find the angular velocity of the fan corresponding to each case. So, angular velocity of the fan is omega. Fan rotating with uniform angular velocity rotates at 5, 10, 20 revolutions per second. What is the angular velocity? So, I'll just do the first one. It's 5 revolutions per second. Revolutions per second. What is the angular velocity? So, what is angular velocity? It's radians per second, right? Angular velocity means radians per second, right? So, here you have 5. It is revolutions per second. One revolution means 2 pi radians, right? One revolution means 2 pi radians, right? So 5 revolutions means 5 into 2 pi radians. So it is 5 into 2 pi radians per second. 5 into 2 pi radians per second. Clear? Okay. So it is 10 pi. It is 10 pi radians per second. 10 pi radians per second. Clear? It's 10 pi radians per second. Next. Question 2. An object rotating 3 revolutions per second. It is 3 revolutions per second. Accelerates to 5 revolutions per second. Accelerates to 5 revolutions per second. What is the angular velocity difference of the object here? Pay attention. What is 3 revolutions per second? 3 into 2 pi radians per second. What is 5 revolutions per second? 5 into 2 pi radians per second. 5 into 2 pi, pay attention, stop talking. 5 into 2 pi radians per second. Clear? So you get 6 pi radians per second. Here 10 pi radians per second. So what is the velocity difference? What is the angular velocity difference here? Delta omega. Angular velocity difference is 10 pi minus 6 pi. 10 pi minus 6 pi. Angular velocity difference is 10 pi minus 6 pi. 10 pi minus 6 pi radians per second. Okay. That means 4 pi. 4 pi radians per second. Angular velocity difference is 4 pi radians per second. Clear? Third one. An object is rotating at a speed of 120 rpm. Find the time period. That means periodic time. Find the angular velocity. 120 rpm. 120 rpm. Question is periodic time and angular velocity. Question is periodic time and angular velocity. How to find the periodic time and angular velocity. Okay, so here, pay attention. First, let's find omega first. It's 120. So even, pay attention. Pay attention. Stop talking, everyone. So even 120 rpm is a unit of angular velocity. In a way, even 120 rpm is also a unit of angular velocity. How many rotations per minute? But it's not the main SI unit, okay? It's not the main SI unit, okay? So here this is 120 rpm. That means how many rounds per minute? I need this in radians per second, right? I need this in radians per second. How can I do the conversion? So it's given as that one, right? Yeah, 120 rpm. Yeah. I have to convert this into radians per second. Clear? Now, rounds. Here, rounds means what? 1 round means 2 pi radians, right? So 120, to convert rounds into radians, I multiply by 2 pi. 1 round means 2 pi radians. Clear? Rounds means 2 pi radians. Then I get radians per minute. I need radians per second. If this is for minute, to get for second, I divide it by 60, right? If you get this much per minute, how much for second? You divide it by 60, right? Clear? So what you do is, 120 rpm, to convert into radians, you multiply by 2 pi. Then you get radians per minute. You divide it by 60 to get the radians per second. Clear? So this is omega in radians per second. Omega in radians per second. Which means 4 pi radians per second. 4 pi radians per second. Okay. Next. Periodic time. Now I have an equation. Okay. Now I have an equation for periodic time. What is that? T equals 2 pi over omega. T equals 2 pi over omega. Clear? Okay. So here you have 2 pi. Here you have omega. Omega is 4 pi. Okay. Omega is 4 pi. From this you get the periodic time. Clear? You get 0.5 seconds. This is the periodic time. 0.5 seconds. Clear? Question 4. A fan rotates with a period of 10 seconds. A fan rotates with a period of 10 seconds. That means the periodic time is 10 seconds. Periodic time is 10 seconds. Find the angular velocity. So now T equals 2 pi over omega, right? We derive this. See here. T equals 2 pi over omega, right? T equals 2 pi over omega. Okay. So omega is 2 pi over t. 2 pi over t. So then angle is 2 pi. Time is 10 seconds. Periodic time is given as 10 seconds. Periodic time is given as 10 seconds. Then you get 0.2 pi radians per second. 0.2 pi radians per second. What is the frequency? What is the frequency? Frequency is 1 over periodic time. Frequency is 1 over periodic time. We derive it here. We derived it here. Frequency is 1 over periodic time. So you get 1 over 10 seconds, which means 0.1. Again, one thing to mention, pay attention. Then what is the unit of frequency? What should be the unit of frequency? It is 1 over seconds, right? That means unit of frequency is per second. Unit of frequency should be per second. But there's a name given for that. You have heard that. Hertz. Hertz. There's a name given for that. Hertz. Have heard that word. So you can write it in hertz too. Okay. You can write it in hertz too. Okay. It's per second or hertz. Okay, another unit of frequency. Let's go to question 4 and 5. Exercise 4 and 5, sorry. Let's go to exercise 4 and 5. Finish the whole exercise 5, okay? If you have time, finish the whole exercise 5 and finish the whole weekly revision, okay? Don't keep talking with each other. Just finish everything. Do these question numbers of exercise 4 and 5. Do these question numbers of exercise 4 and 5. There's a question here. To enter the universities, JIT and general English is needed. I think you have to pass general English. No, right? Yeah. I mean, this is the story. JIT is entirely useless, by the way. I mean, I still didn't get the result. I'm out of campus now. So I think it's useless. General English definitely have to write and get a A, okay? This is an English medium class. If you can't get an A for general English, move to the Sunday class, okay? Not even Sunday class. It's also basically English medium. Move to some kind of a single medium class then. Okay, so general English should not be a problem for you guys. Pay attention, everyone. But there's something like this. I mean, the results, JIT, general English kind of stuff. I have seen this happening in usually entrance for some medical universities. In some I'm not talking about top universities, okay? I'm not talking about tier 1 universities like Harvard, Stanford, MIT kind of stuff. The next layer of universities, I have seen, pay attention, I have seen sometimes they have a first interview, not the first interview, first layer automated. I have seen that. Sometimes the first layer of selection is automated. So in many of these automated selections, I'm talking about foreign universities, they don't know the significance of A for physics and A for JIT. A for physics or A for chemistry and A for like general English. I mean, in local levels, it's entirely different, right? A person who get an A for physics and a person who get an A for JIT or general English, it's entirely different, right? But still, in some of these automated first layers, all A's are considered as similar and they just calculate the marks and then only you get the first interview. I have seen this, okay, in many universities. So for that, JIT and general English is quite important if you are applying these kind of universities. Because they don't know the difference between a physics A and a general English A. A chemistry A and a JIT A. So in that case, 5 ways is much convenient, okay? For that case, I have seen that happening for many like mid-level universities, not the highest grade universities. You can't even get 3 A's and you can't even become island first and get selected to MIT sometimes. But to get selected to MIT, like one Olympiad medal is sufficient, okay? I have had such students. Before A-level results, they got selected to University of MIT. Well, number 1 or 2 or 3, I'm not sure about the ranking now. Just only qualification is one physics Olympiad medal, physics or chemistry or something. That's all. No A-level results, nothing. You just get selected to the university. And I mean, these developed countries, they need the brain, okay? That's why. And so, if you have that kind of a qualification like an Olympiad, yeah, anyways, gonna get selected. No big deal. You don't need A levels or A level results. Why? Why do they do that? It's not because they like us or they like the people with the brains. I mean, they are already developed countries, okay? So why do we have to like ruin our brains for this stuff when the Asians are already there to do that, right? There's a bunch of bright Asians ready to burn their brains, okay? Then why we developed people should have to go through that trouble? So they don't actually love us, okay? Okay? I mean, they can just watch a cricket match while Asians are developing the country, right? Yeah, that's why they need all the brain in their country, USA, all the countries. Okay, that's why they need all the intelligent people. That's why you get one Olympiad medal, you're in. You don't have to, they pay you, okay? They pay you to learn there. They pay you to learn there. Why? Not because they like you. It's just the Asian who's ready to burn their brains, okay? Burning the brain is the most difficult kind of thing, okay? It's quite stressful. Yeah, so very bright Asian ready to burn their brain just to make their developed country more developed. Okay, that's how the modern economy works. Is it the time for the interval? How to figure out that? Now the class starts at 3:30, 4:30, 5:30, 6:30, 7:30. Okay, if it's exactly at the middle now, right? Yep. Yeah, I mean, we didn't do much, right? 5:36. Uh, so what are we going to do? You need the interval now? Who needs an interval now? See, no one, right? You guys are never listening. I mean, no point of staying here also. Okay. So your votes are not considered. Anyone else? Okay. Uh, it's 5:37. Yeah. So do these questions. Finish exercise 4 and exercise 5 after the interval. Finish exercise 4 and exercise 5 after the interval. Be here by 5:55. It's enough, right? Yes. So let's start with questions. Exercise 4, question 1. What is the angular acceleration of an object when its angular velocity, be silent, when its angular velocity increases from 100 to 200 in 5 seconds? So angular acceleration is angular velocity difference over time difference. Angular velocity difference over time difference. Angular velocity difference is 200 minus 100. 200 minus 100 divided by 5 seconds. Divided by 5 seconds. So you get here 20 radians per second squared. Question 2. What is the angular acceleration required for an angular velocity to change from 71 radians per second to 50 radians per second in 3 seconds? Again, angular acceleration equals angular velocity difference over time. Angular velocity difference is, it goes from 71 to 50 in 3 seconds, okay? So final angular velocity, always difference is final minus initial, right? Difference means always final minus initial, right? So here the final one is 50, okay? Final one is 50, clear? Initial one is 71. Initial one is 71, clear? Final minus initial gives 50 minus 71, okay? Over 3 seconds. Over 3 seconds. Then you get minus 21 over 3. Minus 21 over 3. That means minus 7 radians per second squared. Minus 7 radians per second squared. Okay. We get minus 7 radians per second squared. So that means actually the velocity is decreasing. Okay. Velocity is decreasing. Okay. This is a negative angular acceleration. We also call that angular deceleration. Okay. Same terms. Okay. Same terms we use. Okay. A negative angular acceleration, we call that a angular deceleration. Clear? We call that a angular deceleration. Okay. Next. Question 3. Question 3. If the speed of a car traveling on a track of radius 5 meters, pay attention, stop talking everyone. Stop talking. If the speed of a car traveling on a track of radius 5 meters changes from 8 to 28, what is its angular acceleration? What is the angular acceleration? So in that case, speed goes from 8 to 28. Speed goes from 8 to 28. Okay. What is the angular acceleration? Time takes for this process is 4 seconds. Radius is 5 meters. Radius of the track is 5 meters. So let's first find the angular velocities. V equals R omega. Pay attention. V equals R omega. Omega equals V over R. Omega equals V over R. So in this case, we get, omega 1 equals here 8 meters per second, right? So velocity is 8. Radius of the path is 5 meters, right? Radius of the path is 5 meters. Radians per second. Then omega 2. Linear velocity 28. Linear velocity 28. Linear velocity 28. Radius again 5 meters. Radians per second. Radians per second. Okay. Radians per second. Then here, angular acceleration is delta omega over delta t. Angular velocity difference is 28 over 5 minus 8 over 5. Angular velocity difference 28 over 5 minus 8 over 5 divided by time. Time is 4 seconds. Time is 4 seconds. Okay. Then when you solve this, you get 28 minus 8 means 20. 28 minus 8 means 20. 28 minus 8 is 20. Here 5 and a 4. 5 and a 4. Then you get 1 radians per second squared. 1 radians per second squared. Is tomorrow a school day or a holiday? School day. After that it's holiday, right? Question 3. This is question 3. Question 4. Question 4. Question 4. What is the angular velocity of an object starting from rest and moving with acceleration of 10 in 5 seconds? Again, fourth one. First of all, write this down. If you have anything to write, quickly write this. Question 4. Question 4. What is the angular velocity of an object starting from rest? Omega. Start from rest. Start from 0. Hey, stop talking. Pay attention. Yeah, come to the front row. Yes, I mean I was waiting for like you to like catch you for a while. So come to the front row. Yes, yes. Quickly, quickly, quickly. No, no. Front row, front row. I'm not gonna continue teaching until you are here. Come on quickly. Yes, you can bring a friend if you like. Can't help that. It's an internal matter. But anyways, you have to come to the front row. It's good here. Just stay once and feel the difference. You can learn a lot here. And there's a complaint from them that everyone there talk, but I always take them to the front. So yeah. So it's due to the same complaint from your friend. It's good, right? Okay. So you two talk, one guy would be here, okay? Okay. Uh, what is the angular velocity of an object starting from rest and moving with an acceleration of 10 radians per second in 5 seconds? If the radius is 3 meters, what is the speed in 5 seconds? Pay attention. Pay attention. Uh, acceleration equals again delta omega over delta time. That means omega 2 minus omega 1 over time. So acceleration is given as, pay attention, acceleration is given as 10. Acceleration is given as 10. Angular velocity difference, it's omega 2, I don't know. Initial angular velocity is 0. It goes from 0 to omega 2. It goes from 0 to omega 2 in 5 seconds. In 5 seconds. 0 to omega 2 in 5 seconds. So omega 2 should be 50 radians per second. Then the velocity v2 is r omega 2. R omega 2, radius is 3 meters. Radius is 3 meters. Omega 2 is 50. Omega 2 is 50. 150 meters per second. 150 meters per second. And the next one would be the person who turns red, okay? Question 4. See, now already red. Okay. Exercise 5. A bit here. A man starting a motion from rest in a circular path acquires Pay attention. Acquires an angular velocity of 100 in 10 seconds with uniform angular acceleration. Find the angular acceleration of the man. Find the angle through which the man turns in 10 seconds. Number of rounds in 5 seconds. If the radius of the track is 10 meters, find the time taken to attain a speed of 25. Okay. So what is the equation? The man starting a motion from rest. Starting angular velocity 0. Acquires an angular velocity of 100. Final angular velocity 100. 10 seconds. Time 10 seconds. In 10 seconds. Angular okay. What is the acceleration? Omega minus omega naught over time. Acceleration equals omega minus omega naught over time. So final angular velocity 100. Initial angular velocity 0. Happens in 10 seconds. Happens in 10 seconds. So 10 radians per second squared. 10 radians per second squared. Question 2. Question 2. Find the angle through which the man turns in 10 seconds. Pay attention. Stop talking. Angle could be taken using this, right? There's a bunch of equations. I'll use theta equals omega naught plus omega over 2 into time, right? What is this? What is this? Equivalent of S equals u plus v over 2 into t. Okay. Why? Omega naught is given 0. Omega is given 100. Time 10 seconds. You get 500. 500 radians. 500 radians. Clear? Question 3. Number of rounds the man turns in 5 seconds. So they are asking about 5 seconds now. Since I know the acceleration, I'll use theta equals omega naught t plus half alpha t squared. Okay. What is this? What is this? Equivalent of S equals ut plus half at squared. S equals ut plus half at squared. Clear? Angular version of S equals ut plus half at squared, right? So theta equals starting angular velocity 0. Omega naught is 0, right? Starting angular velocity 0 plus half. What is alpha? What is alpha? Alpha is 10 radians per second squared. Alpha is 10 radians per second squared. Then they are asking what is happening in 5 seconds. 5 seconds. So you get angle equals here 5 into 5 squared 125 radians. 125 radians. Next. If the radius of the track is 10 meters, if the radius of the track is 10 meters, find the time taken to attain a speed of 25 meters per second. First of all, this is an angular motion question. So convert this into angular velocity. V equals R omega. So omega equals V over R. Omega equals V over R. So velocity is 25. Velocity is 25. R, radius is given as 10 meters. 10 meters, which is 2.5 radians per second. 2.5 radians per second. Now, what is the time taken for this? Let's use omega equals omega naught plus alpha t. What is this? Angular version of V equals U plus AT. Angular version of V equals U plus AT. Clear? Clear? So you need to reach a velocity of 2.5 radians per second. You need to reach a velocity of 2.5 radians per second. Starting angular velocity 0 plus angular acceleration 10. Angular acceleration 10 into time. From this you'll get the time mass. 0.25 seconds. 0.25 seconds. So pay attention. What I need you to do is refer to things from its linear version. Okay. Because I mean, otherwise, if you keep thinking everything from the beginning, it's a lot of trouble. So just think, okay, final velocity is given, initial velocity is given. They are asking the angle, that means the displacement. What is the equation between displacement and final velocity and initial velocity? It is S equals U plus V over 2 into T, which means theta equals omega naught plus omega over 2 into T. Because we did projectiles, we did different linear motion questions. There's a quite bit of experience in linear motion. Okay, by now we have a good experience in linear motion, right? Here, so you can't build the same level of confidence in angular motion. Okay, you can't build the same level of confidence in angular motion. So what you have to do is, because when it comes to complex questions, you'll see things better in linear version, right? So always refer to things using its linear version. Okay, then you'll remember the equations. Okay. For now, what I need you to do is do a small conversion between angular motion and linear motion and figure out the equations. When you keep doing that, after a certain point, you'll be directly writing the angular motion equations just like you did in linear motion. Okay? Here. So just for the beginning, refer to the linear motion and figure out the equation. Okay? That means when omega naught and omega and time is given, think of it as un, p and t is given. Now think which equation will you use in linear motion? P minus u over t equals a. Then write the angular version of it. When you come here, they are asking for the angle. That means the displacement. What would you do when you need displacement and when you have these three? You will write S equals u plus v over 2 into t. So write the angular version of it. Omega naught plus omega over 2 into t. Clear? Put omega naught, put omega over 2 into time is 10 seconds. Clear? That way it's much convenient. Just building the same level of experience in angular motion takes time. Instead, let's use the experience we have in linear motion. And these days you are getting a lot of holidays. So do a lot of work, okay? You are not getting holidays? Have schools always. Ah, yes, right? Have nothing to do about that. So especially government people, government school people, you get a lot of holidays, okay? Use that efficiently, okay? Use that efficiently. Why? Whether you like it or not, there's a bunch of students, okay, who are using that, okay? So the lead that they take within this time, these kind of holiday periods, the lead that they take, you cannot catch that ever, okay? Why? When school starts, there's a lot of work. So definitely there's a amount of time that you can work per day, okay? Definitely there's a amount of time that you can work per day. So within these days, there are people working a lot, okay? So you will never be able to catch them, okay? You'll never be able to catch them after the holidays, okay? Okay. And at the end of the day, this is a competitive exam, okay? So what matters is like how efficiently are you working compared to others, okay? And at the same time, okay, another common question, like we are home the whole day, but the problem is it's difficult to work like that. It's difficult to work for 6 hours, it's difficult to work for 7 hours, 8 hours, 10 hours. Yes, then figure out your own method for that, okay? Maybe like maybe 5, 6 people or 3, 4 people can get together and work, okay? At the university, there's like 100 exams, okay? There's like 100 exams, but we feel nothing, not a special happiness after the exam. Why? The exam period is, it's fun. Why? You just get together to a boarding place, to the university or to a house, okay? Then you just, at the morning you collect a lot of food. Then you get some kind of a speaker. You put on some music. There's a bunch of people. There's food. You just start working, okay? You're not just burning your brain. You're just having fun, talking with each other, working for maybe 1 hour, and one person figure out something others can't understand. So the person start teaching that, okay? Then again we start working together. Then after 2 hours, okay, then we go out for some food again back, do some work, again food, okay? So it keeps on like that. Then we like choose one person and like keep humiliating the person for the whole time, okay? It's a so time just pass, okay? Time just pass. It's not a lot of work. It's not a lot of work then, right? You can work for 8 hours, 10 hours, 15 hours, no big issue, okay? That way. So just come up with that kind of methods, okay? If you can't work alone, work with few people. Then it's fun, okay? Then it's fun. Then it's not a huge burden, okay? then it's not, then you don't feel like working long hours. Then you won't feel like working for 5-6 hours continuously, 10 hours. No, you can just work. Okay, okay, like that. Figure out methods and somehow work for hours. Okay, because there are people working like that out there. And the next day we distribute the lesson within the people. That means this one should study this area and should figure out, somehow should figure out this area. You should figure out this area. You should figure out this area. Then the next day, it's not studying. First person teach others, then the second person teach others, third person teach others. Like that, come up with your own ways of using the time efficiently, okay? It's only 2 years. After that, you have to write A levels, okay? And it's a lot of work, okay? It's a lot of work. This is a very huge syllabus, okay? Question 2. Question 2. Malik. A fan rotating with an angular velocity of 5 radians per second acquires a new angular velocity by rotating through an angle of 42 radians in 3 seconds. Starting angular velocity. Stop talking, everyone. Pay attention. Starting angular velocity 5 acquires a new angular velocity. We don't know that. By rotating through an angle of 42 radians. Angle is 42 radians in 3 seconds. Time is 3 seconds. Time is 3 seconds. Find its angular acceleration. Okay. So omega naught means u. Theta means s. T means t. They are asking for the angular acceleration. Angular acceleration means a. Angular acceleration means a in linear motion, right? So what is the equation with these 4 quantities? What is the equation with these 4 quantities? S equals ut plus half at squared, right? S equals ut plus half at squared. So S means, so angular version of it is theta equals, pay attention, stop talking, omega naught t plus half alpha t squared. S means theta, u means omega naught, a means alpha. Okay. So now angle is 42 radians. Omega naught is 5. Omega naught is 5. Time is 3 seconds. Time is 3 seconds. Plus half alpha we have to find. Again time is 3 squared. So you solve this and you get alpha, right? So what is the answer for alpha here? What is the answer for alpha? Did anyone got the answer? 6. Alpha is 6. Alpha is 6 radians per second squared. Alpha is 6 radians per second squared. Next. Question 2. Find the angular velocity acquired in 3 seconds. Angular velocity acquired in 3 seconds. If I need to find the velocity, I use usually v equals u plus at, right? Clear? If I need to find the final velocity, I usually use V equals U plus AT, right? So here I'll use omega equals omega naught plus alpha t. Omega equals omega naught plus alpha t. Equivalent of V is omega, equivalent of U is omega naught, equivalent of A is alpha. So omega I need to find omega naught 5, right? Omega naught 5 plus alpha is 6. Alpha is 6. Time is 3 seconds. Time is 3 seconds. Time 3 seconds. 23. 23 radians per second. 23 radians per second. If the blade of the fan is 2 meters long, find the speed of a point on its edge after 3 seconds. So this is the fan. This is the blade. The length of a blade is 2 meters. Length of a blade is 2 meters. Then what is the linear velocity? Currently the angular velocity is 23. Pay attention, stop talking. Currently the angular velocity is 23. Clear? So use V equals R omega. V equals R omega. Radius is 2 meters. Radius is 2 meters. Omega is 23. Omega is 23. So you get 46 meters per second. 46 meters per second. You got the weekly revision, right? Just keep doing that, okay? If you're done with exercise 5, finish the weekly revision, okay? I mean, many of you guys can handle the exercise, okay? But I can't rush. I have to get everyone. This is a new lesson, so I can't rush. I have to teach everyone. That's why I'm moving in this speed, okay? I see many of you guys have finished the exercise. So just move forward, okay? Don't waste time. Move to the weekly revision, okay? And about the paper class, this week we are starting the paper class 6 to 9 this Sunday. 6 to 9. It's 6 or 6:30. I can't remember. 6 or 6:30. 6. Okay. Just write on a sheet if you have any issues like a class or something like that. I can't change the date, but I can make it 6:30 if needed. Okay. Just let me know if there's that kind of issue. Otherwise, we'll be starting at 6. But there's a problem, right? Well, and like about the paper class, there are 4 paper writing slots, or 4 or 6, I can't remember. There were 6 paper writing slots. Whatever the time, you can come here and write the paper properly within the given time, or else you can go to the website, Syzygy website, and submit the paper. Okay. Then the marks will be provided by Sunday, and the mark list will be produced by Sunday. And Sunday evening, you have the discussion of that paper. That is the plan for the paper class. Now this Sunday we are starting. But there will be, for now, one exam per month. For now, there will be one exam per month where we bring you at the school time, morning, Friday morning or Thursday morning, or I'll inform the date. You'll be writing a 5-hour paper, 2-hour MCQ and 3-hour essay. You'll get a break in between. So you write 2-hour MCQ, half an hour break, 3-hour essay continuously here, okay? That will be held as a proper exam, okay, for everyone at the same time. It's once per month for now. It will be twice per month. Maybe after like 2-3 months, okay? Okay. Yeah, for now the paper class would be from around 6:30 to 9 without interval, continuously 2 hours. Okay, 2.5 hours continuous. That will be sufficient for finish the full paper for now. Okay, it will be starting around 6:15 because the problem is Sunday class students, they have the class until 6. So it's not convenient to start exactly at 6. So it will be around 6:15. Okay, it will be around 6:15 to 9:15. Okay, it will be around 6:15 to 9:15 paper class. Okay, this Sunday we are starting. Okay. So that's about the paper class, and tomorrow the paper is finished. Okay. By tomorrow, this week's paper is done because we have to mark it by Sunday. So you can write the paper after tomorrow. But even tomorrow, anytime you can write it online, okay, through the website. And physically you can write from 3:30 to 6:30 tomorrow also. Okay, check the group. All the information is available in the group. Okay. So like if you are planning to write the paper, write before tomorrow night, okay? Right before tomorrow night. Yes, we have to mark and produce the mark list by Sunday before the discussion. Okay. So if you missed, pay attention. If you missed to write the paper this week, no big issue, still join the session this Sunday, the discussion, and the class plan will be informed there. After that, from next week onwards, write the paper if you are not able to write the paper by tomorrow, okay? 3. A wheel of radius 10 centimeters a wheel of radius 10 centimeter. Pay attention, stop talking. Pay attention. A wheel of radius 10 centimeters starts rotating about its axis with a constant angular acceleration. After 20 seconds, its speed is 800 rpm. At t equals 20, speed is 800 rpm. What is its angular velocity? What is its angular velocity? V equals r omega. And here it's not required. in how many? In 20 seconds, right? Yeah. So angular velocity omega should be in radians per second. Stop talking. So it's 800. It's 800 rounds per minute. Rounds, to convert them into radians, multiply by 2 pi. Multiply it by 2 pi. Then you get radians. Divide it by 60 to get per second value. Okay? Then you get omega. So you get roughly 80 pi over 3. You have to solve these for final answers, okay? Put pi equals 3.14 and solve, okay? You can't keep answers like this in the paper, okay? Convert pi, put 3.14 and solve until the final answer. Radians per second. Radians per second. Next, acceleration of a point on its circumference. Acceleration of a point on its circumference means, pay attention, acceleration of a point on its circumference means the linear acceleration, right? Angular acceleration is for everyone, right? So when they ask the acceleration of a point of a circumference, that means the linear acceleration of this guy. Okay. So how can I get A acceleration? I can use A equals R alpha, right? I can use A equals R alpha. For that I have to know alpha. For that I have to know alpha. Alpha means angular acceleration. That means omega minus omega naught over t. So current angular velocity is this, 80 pi over 3. Current angular velocity is 80 pi over 3. Initial angular velocity was 0. We started at 0. We started at 0. Went from 0 to 80 pi over 3 within 20 seconds. Within 20 seconds. Within 20 seconds. So you get 4 pi over 3. You get 4 pi over 3 radians per second squared. 4 pi over 3 radians per second squared. Okay. This is the acceleration. Radians per second squared. Now I can find linear acceleration. A equals R alpha. Radius is 10 centimeters. Radius is 10 centimeters. Radius is 10 centimeters into alpha is 4 pi over 3. 4 pi over 3. This is the linear acceleration meters per second squared. Here. First one. This is the second one. What is the angle turned in about 20 seconds? They are asking the angle turned. That means actually the displacement, right? Pay attention. They are actually asking for the displacement. So, that means angle means displacement, right? Angle means displacement. People there in uniform, pay attention. You guys pay attention. Okay. So, I mean, you actually don't have to pay attention, okay? Because I mean, if this is easy, you don't have to pay attention, but you can't disturb others, okay? That's the rule here. I don't care, okay? I mean, you know that, right? That's why I never blame when you come late to the class. I never blame, right? Because I don't care. It's not my life, okay? That's how I am. My problems are my problems. Your problems are your problems, okay? That's how I live, okay? That's why I live happily always, okay? As a person, I'm happy, okay? I'm always happy because I know the line between me and others, me and the world, okay? It's the most convenient way to live happily, okay? If I get angry when you come late to the class, why should I? I mean, I have already finished my degree. I'm an engineer. Why should I care? Okay? Why should I care? That's how I live, okay? Can't help. Because I mean, if I was teaching grade 6, 7, I would be strict, okay? Why? Because they don't have enough intelligence to figure that out, okay? That coming late to the class or anything, okay? Not listening, not doing homework, this kind of stuff. Grade 6 students, 7 students, they don't have enough intelligence to understand that. So I would be strict. But for A-level people, okay, we don't have to be strict, right? You are just making decisions, okay? You are just deciding to come late to the class. So you just feel free to make your own decisions, okay? It's your life. That's why I don't care. Okay? So the rule in the class is you don't have to pay attention, you don't have to listen, you don't have to do anything, but you can't disturb others. It's a crime. Okay? It's their life. Okay? It's not your life. So you can't disturb others. You can't be loud. You can sleep, but still you can't be loud. Okay? That's the rule. That's the only rule in the class. Okay? You can't be loud because then your decision makes an impact on others' life. It's not right. Okay? Your life is your decision. Okay? At the end of the day, it will always turn okay. Why? There were students who were shouting in the class. They failed. But still they are living a happy life, okay? They went for private universities. They did their own stuff. Some people started businesses. Some people started handling their parents' businesses. Some way or other, they are successful, okay? So yeah, things will turn right, okay? Things will turn right. So that's why I don't worry. At the end of the day, everyone becomes successful in their own ways. Okay, so sometimes you are not listening because that's how it's meant to be. You are meant to fail A levels and sometimes be in a better place, maybe. Who knows? Okay, who knows? So I'm not going to disturb personal decisions, okay? I never disturb personal decisions. That's why I don't get angry when you come late to the class. I don't care. Okay, I actually don't care. If you coming late to the class affects my degree, yes, I would care. But I mean, it's not happening, right? I'm already done with the degree. So that's my mentality. So the rule is feel free to not to listen, feel free to sleep, feel free to stand up and go home, but don't shout, okay? You can't disturb others. That's the only rule in the class. Because your personal decisions should not affect others. Your personal decisions should affect only you. Okay. Three. Three. What is the angle turned in 20 seconds? Pay attention. What is the angle turned in 20 seconds? Theta. We have to find theta. So we have a lot of information here. We have alpha. Now we have alpha. We have actually we have omega and time too, right? Then we don't need alpha, right? Why? We have omega naught. It's 0. We have current value of omega. What is that? What is the current value of omega? 80 pi over 3. Current value of omega. 80 pi over 3. 80 pi over 3. Time 20 seconds. Time 20 seconds. Time 20 seconds. Time 20 seconds. Okay. So what is the equation to find theta? Omega naught plus omega over 2 into t. Omega naught plus omega over 2 into t. So omega naught is 0. Omega naught is 0. Omega is 80 pi over 3. 80 pi over 3 over 2 into t. T is 20 seconds. This will give you the angle. This will give you the angle. What is the number of laps or turns traveled during that time? What is the number of laps turn traveled during the time? If I solve this a bit, then you get 800 pi. 800 pi. 800 pi over 3. 800 pi over 3 radians. 800 pi over 3 radians. Okay. Then number of turns is actually theta over 2 pi, right? It's theta over 2 pi, right? Pay attention, stop talking. It's theta over 2 pi, right? Why? 2 pi means one round. So you divide the whole angle by 2 pi, right? You divide the whole angle by 2 pi. Okay. So theta is the angle which is 800 pi over 3. 800 pi over 3 over 2 pi. Over 2 pi. This is the number of rounds. Okay. This is the number of rounds. You divide it by 2 pi. Okay. Only focus the whole question. Now he's turning red when I look at that direction. Actually, my brain is capable of functioning like neglecting everything happening around. I mean, I'm actually having a terrible fever at the moment, but I mean, you don't notice that, right? You don't notice that, right? I don't think so. Yeah, I'm barely functioning at the moment. I'm barely functioning at the moment, but I don't think that you notice I'm capable of doing it, handling it separately from the fever. You will never notice. Okay, let's go to the seventh one to see a bit different question. Let's go to the seventh one. Just let me know if you have any questions. Let me know if you have any questions. Yes, there's a request to postpone the to make the class start the paper class at 6:30. But I mean, I need enough information for that. Okay, so if you have any kind of issue, if you are planning to join the paper class, and if you can join that physically or online, if it is at 6:30, just let us know. Okay. Otherwise, it would be around 6:15. No point of delaying it than 6:30. Then it will be night when we end the class. But I need enough information. If there's enough request, we can start at 6:30. Just let us know. Just write a cheat. Or just let us know directly. Let's move to question 7. A bit different question. Pay attention, everyone. Pay attention. Last rows, pay attention. Yes, you. Yeah. Okay. Question 7 shows the relationship between angular motion and linear motion. Okay. That means you have a small wheel here and a bit large one here. Okay. The transmission belt, pay attention, second row. The transmission belt running around the rim of a, okay, it's just a functionality of a bicycle, right? How it functions. If the angular velocity of A is 100, what is the speed of the chain? Okay. A and B are 40 centimeter and 5 centimeter. A is 40, B is 5. A is 40, B is 5. If the angular velocity of A is 100 radians per second, this is A, this is B. If the angular velocity of A is 100 radians per second, omega A is 100, what is the speed of the chain and the angular velocity of B. Okay, this is the idea. Chain is connected here, right? Chain is connected here. So the chain will have the linear velocity belong to this point, right? Chain will have the linear velocity that belongs to this point, right? Clear? So the velocity of the chain would be equal to the linear velocity of this circumference, right? Because it's connected there. Clear? Clear? So I can write V equals R omega. V equals R omega. Clear? V equals R omega. Okay. So the radius is 40 centimeters, right? Radius is 40 centimeters. 0.4 meters. 40 centimeters means 0.4 meters. Omega. Omega. It's 100. Omega. It's 100. Clear? 40 centimeters into 100. Clear? Then you get 40 meters per second. 40 meters per second. Okay. Next. So this is the linear velocity of the chain. So as a result, linear velocity of this point is also V, right? It's the same chain. Clear? It's the same chain. So as a result, the linear velocity of this point will also be equal to V. Clear? So I can apply V equals R omega to this one too. Okay. So the linear velocity at this point will be same because it's the same chain, right? So linear velocity will be similar. Linear velocity will be similar, 40. Okay. R is 5 centimeters. Clear? R is 5 centimeters. 0.05 meters. 5 centimeters means 0.05 meters. Clear? Into omega B. This is omega B. Clear? So omega B will be 40 divided by 0.05. That means 800, right? 800, right? Yes, right? 800 radians per second. Clear? 800 radians per second. Clear? Question 2. Question 2. Question 2. If the angular velocity of B is 100 radians, what is the speed of the chain and the angular velocity of A? If the angular velocity of B is 100, it's the same thing, the opposite direction, right? I'm not going to do the second one. You, from using B, you get the chain. From the chain, you get A. Same thing, the opposite direction, right? 3. If the speed of the chain is 100, what is the angular velocity of A and B? So it's quite easy. V equals R omega. Omega equals V over R. Omega equals V over R. So now, velocity is given as 100. So for A, omega A will be, velocity of the chain is 100. Velocity of the chain is 100. Radius is 40 centimeters, right? 40 centimeters means 0.4 meters. This is the angular velocity of A. Then what about B? Omega B equals, linear velocity of the chain is 100 again. Radius is 5 centimeters, 0.05 meters. Fourth one, if B increases its angular velocity by 2 radians per second squared, what is the acceleration of A? Quickly write this down. I mean, in teaching, I have a rule actually, like, I have seen a set of teachers following this. Like, if you are paid to teach physics, you should teach physics and go home. Like, you should not try to shape the personal life of your students, because there's a diversity for a reason. So everyone like is capable of doing a lot of stuff if they maintain that diversity. That's why I never ask you to be like me. Okay, don't. Okay. That's why I never ask you to be like me. Like, I'm getting paid to teach physics. I teach physics and go home. That's all. I never try to, like, it's a crime to shape people's personal life that way. It's not good to do that. Be like me. What a dumb target. Okay. Be yourself. Try to be someone. Like, people have their own diversities due to a reason. People, I mean, although you enter here to with the target of being engineers and doctors, some people ends at management, some people ends at politics, some people ends at music, some people ends as engineers, some people ends at doctors, some people ends at family doctors, some people ends as surgeons, because everyone have their own personality traits. Okay, so don't destroy that, keep that. Don't try to be someone else. Don't look at your teacher and think, okay, I'm gonna be like him. No, just be your own self. Okay, that's why I never try to shape your personal life. Okay, next. If B increases its angular velocity by 2, what is the acceleration of A? I'll create a direct equation for this. Omega A, sorry, alpha A, alpha A, and alpha B. Pay attention, pay attention, stop talking. Pay attention. So it's alpha A and alpha B. Here you have the radius RA. Here you have the radius RB. And the chain will have a linear acceleration of A. Chain will have a linear acceleration of A. So A equals R alpha. It's the same A for the chain, right? So A equals RA alpha A and A equals RB alpha B. Okay, that's how many transmission systems work actually. Okay, that means in the bicycle you rotate it faster and the wheels move slowly but with a good strength. Okay, so in a bicycle what happens is the thing is, pay attention, what happens in a bicycle is you are capable of rotating this wheel faster. So we provide you a pedal here. You are capable of rotating this faster. What you are not capable is providing enough strength. Providing enough strength. Okay. But with this kind of a mechanism, what happens is, okay, because it's difficult to provide enough strength to push your whole body and the bicycle forward, right? But you are capable of rotating your leg faster, right? So what we actually do is, with this mechanism, what happens is, okay, with this mechanism, what happens is, as you see, alpha B equals RA over RB alpha A. RA over RB alpha A. So, see, alpha A you have here, RA is much smaller than RB. So this is going to be small. That means this one is going to rotate slowly. Okay. This one is going to rotate slowly. Okay. But when you pedal here, okay, clear? I mean, you can see the other way too. That's why you have gears in a bicycle, okay? Small gears in a bicycle, you can see both directions. But what happens here is, pay attention, what happens here is, you rotate this faster, the whole energy or the work done by you through all these circles is given to rotate one circle. So the work done by you in a bunch of circles, in a bunch of rotations, is used to rotate the wheel of the bicycle by one round. So what we are doing is we are aggregating or combining the energy given by you in several rotations. You rotate this faster, clear? You rotate this faster, clear? We combine the energy provided by you or the work done by you, clear? We combine the energy provided by you or the work done by you in multiple cycles and give it here, clear? And give it here. Use that to rotate one circle, clear? So when you are capable of providing a smaller energy once, what we do is we let you provide that in multiple cycles, combine them and give it here. Here? Here? That means you rotate multiple cycles with a lower strength. It is transmitted to the bicycle as a higher strength in one circle. Here? And what happens when you shift the gears? This mechanism changes. Sometimes when you rotate one cycle, bicycle rotates one circle. But then it's difficult to ride the bicycle. But you move faster. When we shift gears in bicycles, I don't know how many of you guys have bicycles with gears. Okay. So some bicycles don't have gears. Okay. So you have to have a proper mountain bicycle for that. When we shift gears, even in a vehicle, that's what happening. What is happening? This chain jumps into different circles. When you shift gears, what happens is this chain jumps into different circles. Clear? Pay attention. Then sometimes this radius is equal to this radius. Then what happens? When you rotate one cycle, bicycle rotates one circle. But then it's difficult. But it moves faster. Clear? So that's actually the gear mechanism, the same gear mechanism in a vehicle. Okay. all, I mean, not today's vehicle. Today's it's just a program. Okay, nowadays, I mean, take a BID for example. Now, recently there was a malfunction with the speed or something like that. You take it there, they do a software optimization. Now it's working. Okay, so nowadays vehicles are different. Okay, I mean, so it's software now. It's like 80% software, 20% hardware now. But those days, and mainly even today's, actual vehicles, okay, actual vehicles, not electric, actual vehicles still use these kind of mechanisms. Okay, still use these kind of mechanisms. Okay, uh, so now you can get the answer. So here you get alpha b, pay attention, stop talking. Alpha b equals RA alpha A over RB. RA alpha A over RB. What is RA? 40, right? 40. 40 centimeters. RB 5 centimeters. 5 centimeters. 2 radians per second. Angular velocity acceleration is 2. Alpha A is 2. Alpha A is 2. So you get 16 radians per second squared. Radians per second squared. Write this down. Sorry. B. Sorry. We are supposed to find the acceleration of A. B is given as 2. Okay. If B increases its angular velocity by 2 radians, what is the acceleration of A? We have to find alpha A, right? Sorry. But I think we are getting the same answer, right? No? Alpha A. Acceleration of A. So alpha A equals RB over RA alpha B. So what is RB? B is 5, right? B is 5. A is 40. A is 40. Alpha B is 2 radians per second squared. 2 radians per second squared. Okay, you solve this, you get the angular acceleration of A. Write this down. Question? So pay attention. They are just asking it's true that they are just asking the acceleration of A, but by that they are meaning the angular acceleration. Why? A is a rotating body, right? A is a rotating body. So you can't find a linear acceleration for that, right? You can find an angular acceleration for that. Clear? Okay. You can find an angular acceleration for that. So they are just asking the angular acceleration of A, because there's no point of asking the acceleration of A. Then they should mention which point of A. Which point of A. Pay attention a bit. Class is not over. I have to mention one more thing. One additional thing. Pay attention. This is a bit sometimes we may consider as a bit too much for you guys, but I think it's much convenient to learn this. Pay attention. It's much convenient to learn this because you may face this scenario sometimes. Here, I mean, sometimes they may give values things like this. Okay, the velocity of this point is 5. Velocity of this point is 3. And their gap is 2 meters. So definitely this is rotating, right? This is rotating like this. This is rotating like this. This is something additional, okay? Not mainly included in your syllabus. Not mainly included in your syllabus. But I have seen the use case of this in lot of scenarios, okay? It makes your life easy when it comes to a lot of MCQs. So if they ask you the angular velocity of this system, actually the angular velocity can be considered as the velocity difference. Okay, velocity difference. Actually difference here is 8 because they are in opposite direction. Okay, I think yes, I have to take the difference in that way. So it's 5 plus 3 8. Difference is 5 plus 3 8. Why? It's 5 minus 3, right? Opposite. Divided by 2 meters. This is the angular velocity. Radians per second. Clear? This is the angular velocity of this object. How can I tell this? Pay attention. It actually boils down to relative velocity. Why? Now tell me, this point is stationary. The object is connected here. So that means the object is rotating around this point with maybe 5 radians per second. Pay attention. With maybe 5 radians per second. And if you need to find the velocity at this point, what you do is we get this difference r, okay, and to get v, we multiply by r omega. That means velocity difference between these 2 points is due to r omega, right? Velocity difference between these 2 points is due to r omega, right? Omega and the gap between them. Okay. When this velocity is 0, when the velocity of this point is 0, this one becomes r omega. Okay. This one becomes r omega. That means the reason behind the velocity difference between these 2 points is r omega. Okay. Then in the same way, if this point is moving in this direction with a velocity of 3, if this point is moving in this direction with a velocity of 5, okay, what is the relative velocity between them? If this point is considered as 0, if this point's velocity is considered as 0, if this is 0, this will be 8, right? That's the meaning of relative velocity. That's the meaning of relative velocity, right? If this is 0, this will be 8. That is the meaning of relative velocity, right? What is the velocity of this guy compared to this guy? Clear? So relative velocity will be 8, right? When two things are moving in opposite direction, relative velocity becomes 8, right? So if you think that this is 0, this is 8. Clear? Then who's behind this relative velocity between two particles? R omega. R omega is behind this 8. So omega is 8 over r, which means 8 over r means 2. R means 2. Clear? Clear? That means this is the idea. Pay attention. Pay attention. The idea is, if an object moves like this, if in translational motion, the whole system is moving, but there is no relative velocity between these 2 points, right? See, there's no relative velocity between these 2 points. Why? These 2 points move together like this peacefully. Clear? Whole system is moving, but these 2 points move peacefully like this. Clear? Clear? In a rotation, what happens is they move like this. Clear? That means there's a relative velocity between this one and this one. Clear? Rotational motion creates a relative motion between its own particles. Clear? Rotational motion creates a relative motion between its own particles. So for any relative velocity between its own particles, clear? The reason behind that is the angular velocity. So if someone asks you to find the angular velocity of the system, what you do is you take any 2 points of the system. Okay? You take any 2 points of the system. You find the velocities of them. Let's assume this is 5, this is 3. When they are in the same direction, it should be relative velocity is 5 minus 3, right? This particle is moving with a linear velocity of 5. This particle is moving with a linear velocity of 3. Then what is the relative velocity between these two guys? 5 minus 3. Who's the reason behind relative velocity always? R omega. R omega. So if you know the gap, okay, you put r omega here, you get omega 5 minus 3 over r. 5 minus 3 over r. Clear? Clear? That's how it works. Okay? This is bit out of syllabus. Okay? Bit out of syllabus. I mean, not out of syllabus. This is used again and again. But they haven't asked us to teach it this way. Okay? I mean, there's thousands of advantages of relative motion which we don't take in our syllabus properly. Okay? So properly understand. And when object moves like this, pay attention. When object moves like this, it has a motion relative to me, but it doesn't have a motion between its particles. See, they are moving together. If there's a motion between their particles, if there's a relative motion between its own particles, that means it's rotating. Then the reason for this relative velocity between particles is r omega. Then you get the relative velocity 5 minus 3. It's equal to r omega. Yeah? That's how it works. Okay? That's a proper explanation of relative motion. Okay? A proper explanation of relative motion. Clear? Keep it in mind. Okay? If you didn't understand this, Just forget that, it's not required. Okay, you can manage the whole lesson, past papers and everything with the existing knowledge, but it's good to know this. Okay, it's good to know the right physics. Okay, yeah. So let's stop the class for today. Next week I'm starting exactly at 3:30. Be there on time. That's all. Just finish the exercises. Okay, there are some remaining questions in exercise 5. I'm gonna do them next week. So finish exercise 5. Do the weekly revisions. That's all. And paper class will be on this Sunday, 6:15, at 6:15. Yeah, that's all. See you. Answer script for weekly revision 20 will be provided.